Hello, thank you for watching my video. My name is Zach Savanak. I am a marketing analyst with Nancy's Notions, and my project was on RFM segmentation and analysis. A quick introduction. Nancy's Notions is a company that sells sewing, quilting, and crafting goods online and via catalog. These catalog sales generate 55% of sales. As you can imagine, the demographic for us are 65 and older females that identify as quilters or sewers or embroiderers. We are looking to create a new segmenting method for these direct mail efforts that includes catalogs, postcards, anything that's sent by snail mail, and that's called RFM segmentation. This RFM stands for recency, frequency, and monetary. By frequency, we mean most recent purchase. Frequency would be total number of orders placed by a customer, and monetary would be the average spend per order. This new segmentation strategy will be used to determine who we send a catalog to and who we will not. Right now, we do kind of a RFM type segmentation, but it's more a 0 to 24 month buyers and then anyone over that. And then we do a lot of co op, which would be buying into different names lists and mailing out through third party companies. So a little background here would be our direct mail is the most expensive form of marketing. It's about 84 cents per catalog when all is factored in to what it costs to create inside of the company here, and then including printing and then postage for mailing. Catalogs are split into 5 seasons. We do a winter, which would start in January, spring, summer, fall, and holiday. There's generally 3, but a couple of the seasons have 2. So we start by sending to 250,000 customers on the first send, and it goes down from there, as you can see through the different sends, as the catalogs only change on 16 pages. So even though that catalogs are less known for sales these days, as everything is being driven online, this is still an essential tool from us, as it's been how Nancy's Notions got started over 3 decades ago, and it still continues today. People love to get their customers love to get their catalogs. So where our problem lies then is that our marketing budget is being cut by $600,000 for 2018. The biggest proponent for this is that we want to get better and cut direct mail and get more digital, as everyone wants to get more into the low cost acquisition. So we, as a team, have decided that we're going to cut circulation by 18%. So that's total sends throughout the year, catalog sent. So it's going from 3.1 million to about 2.8 million. And then we're cutting the number of catalog sends per season from 13 catalog sends to 12. And then we're going to cut page count from 80 to 64. This is how we're going to realize that $600,000 savings. So we need to be more strategic, and we need to be better at segmenting and making sure we're taking advantage of every send that we have for catalogs, and make sure that we take advantage of high buying customers and not wasting time and money and effort on the least valuable customers. So we want to quickly and accurately predict which customers we should or should not send a catalog to by using this new RFM segmentation. The specifications and designs are that I will be using a multiple linear regression model, as you can see there, where the dependent variable will be the forecasted customer RFM score, and then we have the intercept, we have independent variable, the recency, the next one frequency, next one monetary, and standard error. This design is using a final RFM score with the best customer being a 555 and the least valuable being a 111. This will make sense here in a couple of slides, and we'll get into how this scoring comes to be. But first, the data was acquired using a third-party company. We use a company called Cross Country Computers to manage all of our marketing and sales data. As everything rolls right through them, we're able to put in for exactly what we need. They call it an order, and then we're able to get this data back to us. So it's less work on our end when you can imagine, as I asked for the last 5 years of sales data with all those items there that you can see, including customer ID, the purchase date, unit quantity, unit price, etc. So this would be every individual purchase, every individual sales order over the past 5 years. So this then came back to me in a text file with 2.1 million records. So as you can imagine, there's no resampling was necessary, as this was a complete sales history over the past 60 months. So when I started exploring the data, there were 2.1 million records, as I stated before, and this needed to be rolled up to show each individual customer ID one time, so I can look at their most recent purchase, how often they purchase, and on average how much they spend per purchase. I imported the data into Access, and I was able to make a series of queries that I was able to roll up all this data and get it down to just over 221,000 records. So that's how many customers purchased over the past 5 years. From there, I scored each customer on a scale of 1 to 5 in each of the three categories of recency, frequency, and monetary to give them a score per category there, as 5 being the most, 5 being the best, 1 being the worst. So someone who bought within the past month would get a 5, whereas someone who bought 60 months ago in this scenario would get a 1. You did that for then frequency and then monetary. So then you will get your final RFM score, that 111 to 555. Overfitting here was avoided because the sales data was rolled up by the customer ID, so I didn't have too much information or made it too complicated with 2 million individual records. I made it down to over 200,000 then. Here's a look at the first 10 or so records within that rolled up data. You can see recency months. So that first customer ID purchased 1 month ago, so they get a recency score of 5. They purchased 7 times in the past 5 years, which when this data was split into quintiles, so they the top 20% for each recency, frequency, monetary would give them a 5, 4, 3, 2, 1 that way. So then the monetary average there of over $3,000, which is by far the most, is an easy 5 there. But you can kind of see how that can work out there. Into giving you a final score right here of your 555. So someone could have a 3, a 2, and a 4, and so on and so forth. So there's 125 different options between 111 to 555. So here is total customers shown in a line graph here of all RFM scores. You can see where which scores have the highest, the least, where they fall. So we do have quite a few really, really good customers, and then actually even more less valuable customers. So that's where we're trying to find, is where do we draw that line and not send a catalog, or maybe only send them 6 catalogs a year instead of the 12 to try to maximize our ROI on the catalog, as well as take advantage of our more valuable customers and be able to focus on them. So my final data transformation, I did the multiple linear regression in Excel. I use the actual recency months, the actual frequency bought, and then the actual average monetary spend per customer as the independent variables. And then my final RFM score is the dependent variable on these. So this would give us a simple way to be able to plug in the RFM scores that we will be getting from Cross Country Computers, our third-party database provider. then simply be able to determine right away where that customer falls, if they fall into the send or do not send category. So as you can see, I used a normal probability plot. I wanted to show the normal distribution per the scores, as it's not going to be a linear line, as they're a score of 111 to 555. So it's more of you can see the percentile there through the scores, and then that does build up a linear line. And then there's the regression equation, and then the R square of 98. So I chose the multiple linear regression because it's easy to run, it's simple to interpret, and I did have 3 clear independent variables with the provided RFM data to be able to predict the dependent variable, which is that final RFM score. So I wanted to develop that because we will be getting the data from cross-country computers readied in RFM already. So I won't have to do the first step, rolling up all the data moving forward with cross-country computers. I just had to do it this one time for this project, and to be able to give them that 1 through 5 score in each 3 of the independent variables. So the description of the results here shows that it is a strong model for predicting an RFM score when using the actual RFM numbers. The R square is at 0.93. And then each independent variable is very strong within the model as well. As you can see, they each have a p-value of 0. I know monetary was as close to 0 as it can be before I shortened it up there. So then we got the final equation here to be able to use going forward to predict that final RFM score. In conclusion, this is a good model to predict final RFM scores with using these predictors. They are all good independent variables for predicting this dependent variable. It would be nice to be able to get more specific results by having the output scores in that range already. You do have to kind of either move up or down a number. If you get like 186 or something like that, you have to change it to 155. But it did seem to match the this past data here. So this is really a first step in our new segmenting process. We will be able to use this now while we develop using what we call matchback results. So we'll take actual results from future sales on a catalog during a time frame, match it back to these customer IDs used here to get an actual response rate. So we'll know if per RFM score, that is. So we'll know 555 has a 12% response rate on this catalog, or a 3 to 4 has a 6%. That way we can do break-even analysis, so we can determine where's the lowest spot we can go within the response rate in these RFM segments that we should be mailing to, so we can get even more specific results, and generally even easier results. We'll just know which RFM score is drawing the line. Then we won't have to run analysis every time after that matchback and break-even results. We also in the future want to start adding digital sales data into the model, so we want to be able to combine digital sales into catalog sales. Like I said, 55% of sales are attributed to catalog, but about 65% of sales are input through the website. So we'd like to be able to see where those matches are, and we'd like to add a few more variables into this, such as email responses, just browsing data. There's just a lot of different variables we can use in the digital side. So hopefully this is a good start for us, being able to use this and understand our customers further, who we should be sending a catalog to, so we can maximize profits from there. Thank you for watching. I look forward to your feedback.